Greetings class, we're going to begin the review for the midterm. We're going to cover chapter 1, which is functions and graphs. Then I will have a quick review of chapter 2 and chapter 3 as well. All of them will be on the midterm. So the big deal in chapter 1 are functions. Important terms, symbols, and concepts. Can you sketch a graph? What is a function? And then the big thing I'm going to be asking several questions is what is the domain and the range of the given function? Do you know the difference of the independent variable or input and the dependent variable or input? Typically x is the independent variable and y is the dependent variable. And can you graph? And so I recommend using Desmos. It's very simple. It's a really nice graphing program, and it does everything you will most likely need. One last problem, I don't think this is on your midterm, but the vertical line test. That is a really simple test that if you have a graph, right, you just run a vertical line through it, and if it only touches the graph once, it is a function. Sometimes you have functions like this, circle, so if you run a vertical line through it, it goes through the graph twice, and that is not considered a function. This form right here is a slope-intercept form. You need to become familiar with that if I ask you, about a linear function. One of the examples, or I'm sorry, the types of problems, or what's the word here? One of the applications are the profit, loss, and break-even types of problems. Typically, when dealing with break-even and profit-loss types of analysis, we're using the cost function and the revenue function. And so the cost function is typically given. The revenue function, if you remember, is the revenue is typically equal to the amount of product sold times the price it's going to be sold at. And so some points of reference is that if the revenue is less than the cost, we have a loss. If the revenue is equal to the cost, we have a break-even point. And if the revenue is greater than the cost, we have a profit. So some transformations. We didn't go over all of the transformations, but the key thing here is the 6 basic elementary functions. We have the linear function, the square function, cube function, square root, cube root, and the absolute value function. But in these particular 6 functions, not including the linear function, we're able to do transformations and graphs. This is also where you learned how to complete the square. To get the function into vertex form. If you don't remember how to do that, or you're having trouble with it, I suggest you do some practice problems. All right, 1.3 was the quadratic function, and this basically gives you the x-intercepts of a parabola, of a squared function. This right here, f of x, is equal to ax squared plus bx plus c, is the standard form of a parabola. And so if we want to find the x-intercepts of that function, then we use this guy right here. And so notice the coefficients represent some number. And so you identify the coefficients and then you plug them in. Don't forget this minus sign right here, and don't forget that it is plus and minus the square root of this function right here. And so, oh, again, completing the square, here it is. Completing the square in the standard form, and here is the vertex form. This is a big deal. You will most likely have to do a problem like this. We will not do quadratic regression. We're not going to be covering that. But I will ask you, you probably will be asked what the vertex of a quadratic function is, and probably the maximum, minimum, and the range. All right, polynomial functions and rational functions, and I think there's a section on exponentials and on exponentials. So polynomial function is anything with an exponent, right? So you can have, x squared, x cubed, x to the fourth, x to the fifth, etc., right? X to the n. That's what this guy is right here, x to the n. And so you have a function of those. N is the degree, and a of n is the leading coefficient, right? And again, I really recommend graphing the function in Desmos so you can see what the function is doing. What the function is doing. A polynomial function has no sharp edges. Here's some properties of it. No sharp corners, I'm sorry. And it is continuous. And it has no holes or breaks. Okay. A rational function is any function that can be written like this. Basically a fraction, right? So an example would be f of x is equal to x plus 1 over x squared minus 1. A rational function is a function that has a numerator, that's n of x, and a denominator is d of x, and they are polynomials, okay? The domain of the set is all real numbers so that the denominator is not equal to 0. This is really important. Some rational functions have vertical asymptotes, and in 1.4 there are ways to find that vertical asymptote. 1.5 are exponential functions, right? So f of x is equal to some value b. So for example, f of x is equal to 2 to the x, right? And there are some properties of exponential functions and logarithms. They are related to the logarithmic family. And there are some rules in 1.5 for properties of these functions. One of the examples here, the base that is used most frequently for exponential functions is e. We see this again in chapter 3, but we use them for radioactive decay and compound interest. Here's the function for compound interest, these guys right here. And now, so exponential functions leads us to logarithmic functions. A function is said to be 1-to-1 if each range value corresponds to exactly one domain value. The inverse of 1-to-1 function is formed by interchanging the independent and the dependent variables. Okay? And so why is that important? Because the inverse of an exponential function is a logarithmic function. Okay? So the logarithms are related to our exponential functions. And here, if you're given an exponential, you can rewrite it as a logarithmic function here. Okay? Oh, I'm sorry. If you have a logarithm, it is equivalent to here. This is just the inverse of the logarithm. And again, properties of these functions can be found in 1.6. Logarithms are base 10, are called common logarithms. Logarithms with the base e are natural logarithms, or ln of x. And why do we need to know about these? Because they are going to be seen again once we get to chapter 2 and 3. And that is it for chapter 1.